Hello, my name is Kimberly and I'm a junior undergraduate research fellow in environmental engineering. Today I'm going to be discussing my research on the application of engineered wetland technologies to impaired water supplies. A wetland primarily treats water through microbial processes and can occur naturally or be engineered. The wetlands in my research are only 1 foot deep and do not have any plants due to a geotextile liner that is very similar to a weed barrier you can put in your garden. There are some reliability concerns associated with wetlands, but further understanding of the processes affecting them should contribute to increasing their utilization. To help with this, I worked on 2 separate experiments. First, I conducted an experiment of my own on the Renew It Mindspark testbed. The testbed seemed to plateau in growth, and so this experiment analyzed the question of what conditions cause an increased activity of diatoms and green algae in the wetland. 11 different amendments were added to biomat microcosms and received 12 hours of light and 12 hours of darkness. The pH and dissolved oxygen were measured twice daily, immediately before the light turned on and before the light turned off. These were the amendments used in the 11 experimental microcosms, which included silica, sand, sewage, nitrate and phosphorus, vitamins and minerals, iron, and a control. This graph shows the dissolved oxygen over time. The nitrate, shown by the light green line, was performing really well compared to the other microcosms. I spiked the silica, sand, vitamin, and mineral mix in mineral microcosms with nitrate standard to see if activity would increase. After an immediate improvement, the nitrate and phosphorus microcosms were also spiked. This graph shows the time right before the initial spike to the end of the experiment, which makes it easier to see the impacts of the spike. Here it can be seen that the addition of nitrate greatly increased activity for both spikes. However, the original nitrate microcosms still had the most activity of all the ones that were spiked. The results for pH are very similar to DO. You can see that nitrate was doing the best initially, and when the microcosms were spiked with nitrate, there was a noticeable increase in activity. Ultimately, the nitrate microcosm had the highest levels of photosynthetic activity initially, and adding nitrate increased the biomat activity in the other microcosms. The control had the lowest performance, which demonstrates that the addition of any amendment is better than none. In conclusion, nitrate appears to have the largest impact on increasing biomat activity in the wetland. In addition to my experiment, I also assisted Adam Brady with an experiment on the impact of sulfate on nitrate reduction within a denitrifying wood chip bioreactor. The goal of this research is to accentuate the positives, such as nutrient removal, while mitigating the negatives, such as metal remobilization, within open water wetlands. This is a picture of the experimental setup. The experiment consists of 10 columns with a sulfate gradient varying from 0 to 1,000 milligrams per liter. To assist with this experiment, I made over 200 liters of influent water, prepared standards, conducted nitrate and ammonia assays, prepared full sampling suits, and helped out wherever I was needed. Before this past year, I knew very little about research. I learned a lot, including lab safety and hazardous waste disposal, how to pipette, important acronyms, when assays and how to prepare one, and how to use a bunch of different laboratory equipment, and much more. I'm excited to continue learning and applying the skills I have gained from this experience. Thank you for your time in learning about my research. I would like to give a special thank you to my advisor, Josh Sharp, my mentor, Adam Brady, and the Undergraduate Research Office for granting me the MERV and allowing me to have the opportunity to have this experience. Thank you.